Hello everyone. We want to give you some insights into our SaaS transformation journey, and we want to share how we solved some of the challenges that we assume a lot of you out there are also running into when building a SaaS environment using AWS. So first question to you, James. Let's start with what Lucanet actually is and which situation we were in when we started our SaaS transformation journey.
I'll start off with maybe a little bit of history. When I joined Lucanet 2.5 years ago, we were a market leader predominantly in financial consolidation. So we had a fantastic product, really loved by our customers, great NPS scores. But it was one solution solving one problem, more or less. And it was a large Java monolith, had been developed over the course of 20 plus years, with the company being founded in 1999. And my mission when I joined was to transform that software into a proper cloud native SaaS solution. We'd already, maybe 2 years previously, started to build a cloud offering for our customers, but it was kind of lift and shift really. We just effectively hosted that large Java monolith and everything it required in the cloud for our customers using, I'd say, a fairly rudimentary architecture. Our strategy has evolved, and now we operate across all of the jobs to be done in the office of the CFO. And that produced a whole bunch of different challenges for us because we didn't build all of the extra solutions that we now host on the platform to support the office of the CFO. It's a mixture. So we already had some, obviously, because we had this fantastic consolidation product. But we also acquired some companies along the way. They're all great products, but they're all built in a very different way. And it became very clear quite early on that this was going to have a profound effect on the way that we approached designing our new platform.
Usually when you talk about Java monoliths, people immediately think monolith bad. This is not the situation that we were in, and this is an important aspect of what we are doing. Our product is a highly maintainable Java monolith, and we knew that we do not want to throw away the 20 years of expertise that went into developing this product. So we wanted to have some kind of architecture and some kind of infrastructure that would allow us to keep our product and to keep building upon the strengths of our product while also allowing for efficient new development.
Can you explain our core concepts and architecture and what a so-called tenant pool is and how this fits into our architecture?
Tenant pools are the core level of architecture that we have. They are an isolation level that is more or less unique to our architecture. A tenant pool is, simply put, just an AWS account that hosts all the data and all the services that we require to host up to 100 tenants. And we have deliberately chosen this specific model for its, advantages.
Now, tenant pools in Lucanet are, certainly in R&D department, a completely kind of accepted concept. And we were trying to think back to the point where we actually decided that this was the architecture we wanted to use and how we validated it. And we work very closely with AWS. We have some great colleagues over there who are cloud solution architects that advise us on the best way to use AWS. And we presented this architecture to them. They had questions, and one of the obvious questions was how many tenants do you put in a pool and things like that. But there was actually never any point at which someone said, no, this is the wrong idea, because it felt so natural for the problem that we were trying to solve. And I find that quite interesting, because certainly when we go back and do the trade-off analysis, it still feels like it was the right thing to do. But there was never that point at which we kind of actually said, we'll actually make this decision, because it just, as I say, felt so natural and right that we kind of went with it.
Tell me why you deliberately decided not to go with one account per tenant. Can you also elaborate a bit on the decision why you decided against putting all tenants into one single account, and maybe share the trade-offs of that as well?
There are a few aspects to it, but the most important one is the blast radius minification. When you put all the tenants in one AWS account, if something goes down, it goes down to everyone. And simply put, this is not the degree of risk we are comfortable with taking. There is also the scaling aspect of the problem. There is a whole bunch of account level limitations in AWS that become increasingly painful to work around as you scale up your number of tenants. We can't reliably provision infrastructure for new tenants because we risk running into these limitations all the time with one AWS account for all tenants.
It's very hard actually for us to predict which quotas we're going to run up against, and that sounds a bit odd when you first say it, but actually, because we have these now 7 different solutions and they're all constantly evolving, trying to make the best use of the AWS services that are available, this segmentation of customers into accounts actually feels like it's totally necessary.
And it only gets worse when we start talking about dynamic quotas. There are limits to how quickly you can provision additional infrastructure. And if you are doing this in a tenant pool that hosts hundreds of tenants, then worst case scenario is just them who are encountering this problem. If you run out of this capacity globally, you are having a bad day, and everyone is.
It's the level of integration that we're trying to embody in our platform for all of our solutions. And one option would be actually to run all of these solutions in separate accounts and treat them as separate stacks, which would alleviate some of the problems around quota management, for example, because it would be a little bit more predictable. But it really goes against what we're trying to achieve. Our platform is supposed to support our CFOs and their teams to build these really seamless workflows. And that's the direction that we're pushing in. Everything we're doing is around trying to automate as much as possible for those CFOs, and that's why we're building in a whole bunch of AI agentic flows and all of that good stuff. But in order to do that, you actually need a really high level of integration between all those solutions and the platform. And if you try to host them all separately and don't have a unified way of deploying them all dependably and reliably, I don't think you're ever going to achieve that level of seamless integration that we're trying to achieve for our customers.
Talking about deep integration and security, I assume that these tenant pools still require tenant isolation. Can you elaborate on how you handle this aspect of security in your architecture? And can you please also share with us your authorization strategy?
We actually use a variety of techniques in order to guarantee that tenant isolation, and it is something we take very seriously. We have some parts of the platform and the solutions that are cloud native and serverless, and for those we typically use some, I'd say, fairly advanced techniques around ABAC, so attribute-based access control. And the whole idea here was to make sure that it would be impossible for a mistake by a developer to expose data from one customer to another, because we're handling highly sensitive financial data, and we're working potentially in regulated markets and in territories that are particularly sensitive around privacy, such as the Germany regions. What we did was we avoided one of these situations where you simply maybe put all the data in a database and have a prefix on the column and then leave it up to the developers to build their queries. And we leveraged as much of the AWS platform to do that work for us as we could. So we use these attribute-based access controls, as I mentioned, so that when a request is authorized and that's done actually using Lambda authorizers, typically on API gateway routes. We look at the inbound token, and we can talk a little bit about how the tokens are generated. We look at the inbound token, which is obviously a JOT token, JWT token, and we extract from that a unique tenant identifier for the customer that's making the request. We then impersonate, or rather assume a role, an IAM role, and as we assume that role, which ends up creating a temporary IAM session for us, we take the tenant ID and we put it into the session as a session tag. And from then on in, everything that is cloud native uses IAM constructs and with constraints specifically to make sure that it's actually impossible for our code to successfully cross tenant boundaries.
This level of isolation is actually very secure and reliable, but for customers who want even deeper guardrails, we are also working on something new, something called bring your own key, and what it evaluates to in reality is that the data is encrypted not by keys, not by the encryption keys that are managed by AWS and not by keys that are managed by us, but rather by keys that are issued by our customers outside of the context of the application. And customers need to explicitly provide us permissions to decrypt their data. What this means is that even if all other isolation mechanisms fail and somebody somehow gets access to data, they won't be able to do anything with it. It's just digital noise without the encryption key that the customer is possessing.
Talking about isolation and noise, how do you handle the noisy neighbor problem in your architecture?
Since we isolate up to 100 tenants in a tenant pool, nobody has more than 99 neighbors, and even if there is a noisy neighbor in one tenant pool who makes life miserable for his cohabitants, the other tenant pools remain completely unaffected and continue working as usual.
We also have the ability, when there's a neighbor that is too noisy in a single pool, we can move it from one busy area to more quieter destination. So it helps us be more proactive in our abilities.
Let's look at the efficiency of our platform operation. What are the cost implications when comparing the symmetric versus asymmetric pools?
It's a good question, but I think we have to move one step back before we start talking about asymmetric or symmetric tenant pools, that we have this tool that we built in-house called the control plane. And that's essentially a automated cloud engineer that's active 24 hours a day, 7 days a week. And that's kind of the driving force for making sure that we can maintain both symmetric and asymmetric tenant pools. But what is an asymmetric or a symmetric tenant pool? So we have, as James and Andy kind of touched on, a lot of different solutions, and not all of those solutions need to run in every place at any one point in time. And some of those solutions are actually very heavy. So we require to be able to spin up these asymmetric tenant pools that might have less services or more services for that kind of user or tenant pool type. So essentially, like I said, an asymmetric tenant pool is something that's not the same as everything else.
We offer this complete solution, but not everybody wants to use each part of that solution. And so, our ultimate aim, of course, is to have all customers using the entire platform, but we're not there yet. And so you may end up with an uneven distribution of customers in tenant pools that need to use particular services. And if those services are maybe particularly resource heavy but underused in a tenant pool, then we might decide to create an asymmetric tenant pool and move tenants so that we can get kind of the maximum resource utilization inside that tenant pool.
For some solutions like our platform services, they are incredibly cheap to run and they essentially cost nothing when nobody is using them. They only start costing money when there are people using them. For other solutions, it's expensive to keep them running even when nobody is using them. And it's specifically with these solutions that we are leaning towards utilizing asymmetric tenant pools for the simple reason we don't want to amortize the costs of running these solutions among tenants who actually have no interest in these solutions.
Yeah, Andy and I were talking about this the other day, and it was really interesting because we were reflecting upon where we are now, 2 years after we started this journey, and asking ourselves the question, as you do, did we make the right decision choosing this architecture? And the only conclusion I can come to is that you will never know. You never know exactly what would have happened had you not made that decision. But I am pretty sure that we would have had a completely different set of problems had we not. And some of those problems I don't think I would have wanted to solve.
Thank you all for the talk, and I hope we answered some of the questions you also might have had out there on our concept and the architecture that we used to build our SaaS platform. I hope this was valuable for you, and have a great